There are many different forms of renewable energy. And did you know that many forms of renewable energy start with solar energy from the sun? In this lesson, we're going to talk about other energy sources. So, the sun and the moon's gravitational pull creates tides on both sides of the earth. And we have high tides, low tides, spring tides, not the season, but when they're related to the full moon, as well as neap tides, which are our tides that are the smallest tides of the tidal cycle. So spring tides are the largest tides, highest highs and lowest lows of the cycle, and neap tides are our highest lows and lowest highs of the tide cycle. So the moon has the greatest influence on the tides because it's much closer to the earth than the sun. And its pull is greatest on the water near the moon. So water is going to be drawn towards the moon, causing a high tide. Water is not drawn away from the farther side. So there is a bulge on that side as well, causing a high tide. Low tides occur in areas that are not in a direct line with the moon. And tides occur every 12 hours and 25 minutes on two opposite sides of the earth. So we'll have a high tide every 12 hours and 25 minutes on opposite sides of the earth at the same time. So tidal energy is going to be limited because there's a limited potential as to where this can be placed in the world. So the water needs to be channeled into a bay rapidly, and we often want a narrow bay, and there needs to be a large difference between high and low tides. And because tides only happen every 12.5 hours, the energy can be intermittent as there's a stall where the high tide pauses before it starts retreating again. So the Bay of Fundy is a place where we can have tidal power in Canada because there's a very large difference between the high and low tides, as well as a narrower bay that we could possibly install a tidal dam. So a barrage is built with sluices or channels through which the water can pass. And then that moving water is going to spin the turbines, which will then spin generators, which will create electrical energy. So we would have the gravitational potential energy of stored water, then the kinetic energy of moving water, the mechanical energy of a turbine, and then a generator produces electrical energy. That's our energy conversion chart. We'll see how so many of them end up with mechanical energy of a turbine into a generator to create electrical energy. So there's two basic types of tidal generators. One is generated only when water moves in one direction and not the other. And the other one, electricity is generated no matter which direction the water is passing. So in this cross section of a tidal station, we can see we have the barrage built and then we have the turbine underneath. As the water goes past, it's going to spin that turbine. That's going to spin a generator to create electricity. So geothermal energy is energy from deep within the earth. And we can see this in volcanic activity, geysers, hot springs, as well as geothermal generating stations. And sometimes those geothermal generating stations are hot enough to generate electricity. Other times we can use them as a energy for heating. So we can do this in Alberta, where we can dig down below the ground and get warmer water compared to the air above the ground. And so we'll take this warm water in, pipe it through underneath our floors or in the walls. It's going to release its thermal energy into the air within our house. And then we'll pump the cool water out back underground until it becomes warm again. And so you can do this under pavement on, like, say, driveways and sidewalks. And then you'd have a snow and ice-free sidewalk all winter. When we look at hydroelectric power, again, sun is the original source of energy for hydroelectric power because it controls the evaporation and transpiration of water. Then you have condensation followed by precipitation, which is going to store water in ice and snow or runoff. So when we build our hydroelectric dam, we're creating an area of gravitational potential energy because we have high up water in a reservoir, and then we're going to release water on the lower end of the dam, typically into a river. And as water goes through those channels, it's going to spin a turbine, which is going to spin a generator and produce electricity. When we look at a wind turbine, we again have our initial energy as solar energy because that solar thermal energy is going to heat the air. As that hot air rises, cool air is going to come and replace it, causing a wind to blow. So when we spin those wind turbines, we're going to spin a turbine, which is going to spin a generator, which is going to create electricity. But again, the initial source of energy is the sun. So when we look at biomass plants, again, original source of energy is solar because it will be taken into plants during the process of photosynthesis. Then we're going to cut down those plants or use plants or animal waste, burn it to boil water to create thermal energy, to make kinetic energy and steam, to spin a turbine, to spin a generator to produce electricity. Then when we burn the biomass, that carbon dioxide goes back to the atmosphere where it will be reabsorbed in the process of photosynthesis. So some different things that we can burn for biomass is fuel wood. We can also burn waste wood that is used in forestry and other processing plants, manure from agriculture, crops that are grown as fuels to produce ethanol, plant waste, so things that are not used in food production, part of crops, organic waste from industry like cooking oil, decomposing organic waste in landfills, as well as human waste and manure. So in a hydrogen fuel cell, we put hydrogen in one end and oxygen in the other. And then as they combine, and there's those two electrodes allowing for free electrons to move through the wire, two water molecules are going to be produced during that formation reaction. And we have almost a waste-free fuel production. So here's another example of how electrolysis could work. So we have our photovoltaic cell, which is powered by the sun. We have oxygen and we have water that's going to be then separated into oxygen and hydrogen gases. As it goes into the fuel cell, it's going to combine back into water liquid. And that energy released, the free electrons, are then going to flow through the circuit and power an electric motor or fan. Now, these are all some renewable energy resources that we can use. Would be passive solar energy, so the development of houses to allow for sun to come in the winter, but not the summer. Using the Earth's energy systems like geothermal energy, biomass fuels, geothermal and tidal, which are two that are not solar energy based, but biomass, wind, hydroelectric, and photovoltaic cells are all types of energy that are initiated with solar energy. So looking at the efficiency of different compounds and appliances. So why do we want things to be more efficient? So this lowers the demand of our limited energy supply. And because we're using less energy, we're lessening our environmental impact. Because energy has to be developed, the less we need, the less we have to produce. Being more efficient costs less money, and we can be more efficient by obtaining energy in better ways, using less energy overall when possible. And we can do this by using devices that use less energy and use human energy when possible. For example, going for a bike ride or a walk instead of going for a car ride. So efficiency is a measure of how much energy is used. The other energy is lost as heat. So our percent efficiency is energy in divided by energy out divided by energy in. So our output divided by our input multiplied by 100, because output is always smaller than input. So our efficiency will always be less than 100%. If you end up with an over 100% efficiency, double check your formula. So our efficiency can be increased by using better technology, doing regular maintenance, and improving the design of our buildings and machines. So if we look at an example, during a trip, a car uses 2.35 times 10 to the 7 kilojoules of chemical energy supplied by gasoline. Now, this is transformed into 4.73 times 10 to the 6 kilojoules of the car's potential energy to do useful work. So again, our output energy is 4.73 times 10 to the 6, and our input energy is 2.35 times 10 to the 7. It's important to make note of the superscript of the times 10, because that's where we're going to see our difference in energy, which one's more, which one's less. After we multiply that by 100, we get a complete efficiency of 20%. So that means 20.1. So 79.9% of the input energy is going to be lost into non-useful forms of energy like sound and heat. Another way to improve efficiency is through the process of cogeneration. So using waste thermal energy from one process to power a second process. So we do this in aerodynamic design. Fuel efficient motors have increased car efficiency, but also walking or riding a bike or carpooling are even better. So aerodynamic design will reduce our friction and making more fuel efficient motors. So cogeneration, we would use that hot water, say like from a thermal power plant, to then pump underneath the sidewalks to keep the streets clear, or we would pump it through housing developments to increase the temperature inside those houses. So we would use the thermal energy from that to warm houses. We will also use a process called load scheduling. So we use less electricity during peak times. So when there's a lot of demand on the energy system, governments and power companies will often say, can we not run dishwashers and laundry machines, for example, during the peak energy usage times, such as like 4 to 7 o'clock at night, because that way they don't have to produce more electricity during that time. But people can run those devices when there's less demand on the system so that the system doesn't have to speed up and produce more electricity. So let's look at the risk and benefits of a variety of different types of electrical generation. If we look at fossil fuels, here are some of the costs and risks. They're non-renewable. They are available in limited amounts on Earth. There's a potential for political manipulation because they're available in some countries and not others. We damage habitat when we remove them from the Earth. The combustion of them contributes to global warming, as well as acid deposition and ground level ozone. Some benefits of fossil fuels are they're relatively accessible, convertible to different forms, and affordable. They're storable and transportable, and we have the existing systems in place to refine them. So looking at nuclear energy, some of the costs include they're non-renewable. They're expensive to create nuclear power plants. They create thermal pollution, radioactive waste, which is a big one, and the potential for nuclear weapons. The benefits of nuclear energy, however, are that they produce lots of energy with no gaseous emissions, so they don't contribute to global warming. There are large reserves of uranium available, and they have a typical low operating cost once they're up and running. But that radioactive waste stops a lot of people from being behind nuclear energy. When we look at photovoltaic cells, so this would be like solar panels, there's intermittent solar energy, and that's one of the costs and risks, is that the sun doesn't shine constantly all the time. There can be hazardous levels of arsenic and cadmium used in production. They're costly, and they require a large amount of land, and this could lead to visual pollution, which is just where we see them often in the landscape. So things like wind turbines, people also say have visual pollution, and same do with if there's lots of wells in an area. Some benefits are that it is renewable, there's no fuel cost, no gaseous emissions, no thermal pollution, no chemical pollution, and that they're easily installed. So once we get the cost down, the production using less harmful chemicals, and maybe them being more compact, more solar voltaic cells will be used in energy production. Look at wind. Again, wind power is intermittent, so it doesn't occur at the same time all the time. It typically only produces small amounts of energy. It's costly, and then again, that visual pollution as well as some noise pollution. The benefits are that there may be many sites available for wind production. There's no emissions, no thermal pollution, no chemical pollution. They're easily installed, and there's no fuel costs. So again, that intermittent and lack of efficiency are what are some major drawbacks to solar energy or wind energy. So hydroelectric power can be affected by drought. So if we look in the United States, the river that they've dammed that provides water and electricity for Nevada and California, the reservoir is starting to go down so much because of drought that they're not able to release as much water as they used to be, or there's not going to be enough water left for consumption by people in agriculture. So the production of power there is facing a gray future. There are high construction costs to a hydroelectric dam, which will change habitats both upstream and downstream, which can lead to an increased amount of erosion both upstream and downstream because of the changes of water flow. It does affect the groundwater because of we've reduced the flow of water in a river. This can affect river flow because we have an intermittent speed of water where they can release water or hold back water. And it causes the biomagnification of metals because we have a pool of water where we didn't used to have a pool of water before. And so metals from the ground will typically leach into the water and then can build up in food chains. But some benefits are there is no gaseous emission, so it doesn't contribute to global warming. There's no thermal or chemical pollution, no fuel costs. It adds recreation because now you have a new body of water. Typically, they last for long periods of time and large amounts of energy are produced. So, for example, in British Columbia, they don't pay a power bill, they pay a hydro bill because the majority of their electrical power comes from hydroelectric power plants. So, when we look at biomass, some of the risks include the risk of the solid waste. There's a low energy amount produced. The harvest can damage the soil, it removes nutrients from the soil, and it typically costs more than fossil fuels. The benefits are that it's available in many places in the world and is easily replenished. There's little sulfur emissions, and because we're using short cycling carbon dioxide, that carbon dioxide is offset by replanting. With geothermal energy production, the risks are that there's very few practical sites for fossil fuel production, geothermal fuel production. It does create thermal pollution because now we have hot water on the surface of the earth that we don't know what to do with. It can release some gases like hydrogen sulfide into the air and does create habitat changes and can smell. Some of the benefits are that there's lots of energy in some of those available sites and it costs less to build than other plants. There's no fuel costs and there's less pollution than other fossil fuels. So one of the major drawback is that there are few practical sites for geothermal energy to be built. And lastly, when we look at tidal energy, again, there's only a few sites where this would be available. It can only be produced when tides are moving, and there's a high construction cost that also has habitat changes. However, the benefits are that it's renewable, there's no thermal or chemical pollution, typically relatively low maintenance construction, as well as no fuel costs, and we can build access to it by building roads. So again, the major drawbacks for tidal power are that there's few sites and that it can drastically change the habitat. So thank you for joining us in our lesson on alternative energy sources. I hope you enjoyed.